Hi everyone. We continue again on the topic 3 under the subtopic of sampling. In this video, we will learn how to reduce the gross sample, the sample that we collect from the population into the laboratory size sample. So, what is a gross sample? Gross sample is the sample that we collect from the population site or from the sampling site. This gross sample have to be further treated to make it more homogenized in terms of chemical compositions in particular size. So we have to do the mixing to ensure the homogeneity. The gross samples should be representative of sample to population. So we have to crush or grind the gross sample to reduce the particular size of solid sample, particularly into the size, whereby in the smaller particle size is ready to react with the chemicals that we include during the analysis. And also, if we are dealing with the solid sample, we have to apply the quartering technique to reduce into the laboratory size sample. So quartering technique is to reduce the amount of solid sample from the gross sample to the lab size. However, we have to be very careful when we do crushing and grinding. The chemical composition of the solid tend to change. So it can be changed in terms of chemical compositions due to releasing heat. During the crushing and grinding, the heat will be released, so it will cause the volatile component in the sample will be escaped. And also when we crush or we grind the solid sample into the smaller particle, the surface area will be increased. So when the surface area of the sample that we crush or we grind, it increase the possibility for attack by the atmosphere, and also it increase the higher amount of moisture or higher amount of water will be absorbed on the sample. So and also during do the crushing and grinding to reduce the size, some of the material will be losing. It's a dust. Okay, so we have to use a proper crushing and grinding instrument to reduce the sample size, like we using the jaw crusher, this pulverizer, bull milling, even we can use a mortar and pestle. And after we crush and grind the gross sample, we have to sieving in order to obtain the same particle size of sample. So this is the diagram to show the apparatus that we use during the crushing and grinding. This pulverizer, jaw crusher, bull milling, mortar and pestle. So, as I mentioned just now, quartering technique is the technique should apply when we deal with the solid sample, okay, from the gross sample into the laboratory size sample. So this slide is re-explain what is the quartering technique all about. So first we put the solid sample on the cloud and the cloth, and then we form a cone, we fold over, and then we divide it into 4 sections, okay, like this. So the two diagonal section will be discarded. Another two will be retained and we remix. We repeat the process until we obtain the right size of lab sample for the analysis. Okay. This is showing to you the coning and quartering for the solid sample. We have to mix it the solid sample around until it homogenized before we apply the quartering technique. Okay, so what is the relationship in sampling stages? So during do the sampling, we can divide it into several stages. First, is the population site or it the sampling site is we call it sampling unit. So after we collect the sample from the sampling site, we can have the gross sample, and then we bring the sample into the lab. We reduce it until we obtain the lab size sample. Sampling unit is the minimum size of package in the consignment which a sample may represent the diff. Okay. Okay, dealing with the solid sample, because solid sample is inhomogenized, we do the mixing, we do the crushing and grinding to reduce the size, and we also have to apply the contouring technique to get the right size. Before we analyze it, we have to dry the solid sample. So what is the purpose of drying? We want to ensure the exact weight is obtained during the quantitative chemical analysis. So drying process can be done in many ways. Either we dry in our oven at 105 to 110 degrees C to remove the moisture or to remove the organics, volatile organics traces inside the sample for 1 to 2 hours. Or we can dry the sample using microwave IR lamp. This process is much faster compared to the oven. Or we have to dry the plant in the tissue sample base by using a heating technique. But when we do the drying by applying the heat, so some problem may occur. The sample might decompose at high temperature. Some samples are very sensitive to the heat, so therefore it can we have to drying the sample not in the oven, not in the under the microwave or IR lamp, and not by applying the heating, but we dry the sample in the desiccator. So I think we learned already on the topic 2 what is the desiccator all about. Okay. So as I told you why we dry the sample, because the presence of water or moisture in the sample may alter the composition of the sample. This is why the moisture trapped inside the sample must be removed. But very careful because as I mentioned just now, by heating, the composition may change. So you have to understand the character of the solid sample in order to use the right technique for the drying. Drying sample has to be done because we want to ensure the mass or the exact weight for the quantitative chemical analysis. If drying is not done, drying treatment is not performed, so the weight of sample we reported is basis. Okay. So drying of samples is very the chemical composition inside the samples is very depending on the temperature and also very depending on the humidity around the sample. So if we have a higher temperature or it lower humidity, so the concentration of water inside in the samples are getting low. So thus we need to remove the moisture from the sample by heating. So a little bit a different form of water in solid. The water can be essential water or it can be non-essential water. For the essential water, is a water of crystallization or the water of constitution. So non-essential water is the water absorbed from the atmosphere or the salt water and the trap water of the surrounding. All right. After we are drying the sample, we have to do the sample storage. So, what is the purpose of sample storage? Because there is always a time gap between when we prepare the sample in the time of the actual analysis carry out. For the liquid sample, before we do the analysis, after we do the sampling, we have to keep the liquid sample in the bottle, glass bottle or plastic bottle with the stopper. So if the liquid sample is acidic liquid sample, acidic, so we have to put it in glass container. But if it's just a basic liquid, we can use a plastic container only. Solid sample is more easier to keep because it's less chance, less probability to alter or decompose by the foreign matters because it's a solid samples. Sometimes it's just a matter of sometimes the solid sample is also can be absorbed on the wall of the container or the wall of the sample bottle. So several problems will be encountered during the storage of sample. The samples that we stored in that particular glassware or bottles will be contaminated by the foreign matters. In the sample, when we stored in wherever sample container, we tend to lose of the analyte during the storage, or the sample can be decomposed as well, or they have some side reaction during the sample storage. Uh, the sample should not react with the wall of the container. That will cause the contamination of the sample. This is why, for example, the acidic liquid, we put it in the glass bottle instead of the plastic bottle. Okay, so meaning that whatever procedure taken in the lab, you should have a proper reasons, or you have to you have to choose the right way to do it. During the storage of sample, particularly, for example, a liquid sample, sometimes the liquid, we will lose the analyte because a liquid have a different degree of volatility. If the sample, the liquid is very volatile, so meaning that the analyte that we want to analyze will be evaporate. So you just imagine different liquid, different volatility of the liquid. Like we have ethanol in water. Ethanol is more volatile. It's easy to escape. Water is less volatile. Will be remain is a liquid at the room temperature. So meaning that if we deal with the sample of liquid sample, we have to put it in container with the close tightly in order to overcome the evaporation problem. Uh, Also, we remember during the sample storage, if the temperature surround the storage bottle increase, it will be enhance the volatile evaporation process. So the volatile analyte will be evaporated. Meanwhile, if we decrease the temperature, let's say we put the sample in the freezer, uh, it will be form the deposit or the precipitation of the analyte. The analyte will be deposit or will be form of precipitate. So when we changes in humidity will affect the moisture content, particularly for the hygroscopic solid. Hygroscopic meaning that the sample is very sensitive to the moisture. uh, Maybe UV radiation, we have to think about it. We put away the sample from the UV sensitivity or under the direct sunlight. So this is the things that you have to consider because some in situ chemical reaction will be happen during the chemical storage, during the sample storage. Uh, Physical separation maybe can be happen as well into several layer because it be a different density. For example, if the liquid is oily, so the oily component will be separated from the aqueous component. And also some liquid is induced by the oxidation. For example, if we have a metal sample, so the metal will tend to oxidize. Okay. Before we do the sample analysis, is the flow. We collect the sample from the population, which is a gross sample. We have to reduce the gross sample into the laboratory sample by using a proper technique. And then the sample that we prepared, reduce, we put it the is the sample storage, in following with the replicate of the samples. What is the purpose of do the replication? Because replicating the number of sample will be increase the accuracy of the results. So most of the chemical analysis performed in the laboratory will be do replication, at least try 3 times, replicates 3 samples where the weight or the volume have to be determined by careful measurement using analytical balance for the mass or using the volumetrics device for the volume. Obtaining replication of sample will be improve the quality of the result and provide the reliability of the data. So this is the purpose of do the sample replication, is in order to get the higher result. But put in mind, if you want to do the replicate, the sample it should be in same size, and also do the replication will be increase the cost of analysis. So I think this all this video. See you again on the next video. We will continue on the solution of sample. Okay, bye bye. Thank you.